Hi, my name is Senthil Kumar. Today we'll talk about sharding techniques and framework. Why sharding is required? There are many advantages of using sharding. Okay, so let's take an example. So if you have a large database, okay, you have multiple tables in this one. Say one table is very big table. So what you want to take it is say this is a table. So you want to take the table and then you want to spread it across one or more different databases. And these databases can be on a physical hardware, so where the table data is distributed across multiple tables. So why we have to do this thing? Let's take another example. So traditionally, if you look at a graph where your response time of a query response time, okay, in the x-axis, and then you want to put your data volume in y-axis, So normally what happens is, as the data volume increases, right, your response time is going to be like kind of increasing. As the data volume increases, your response time is going to increase. So this is a nature of how the data growth happens. So when it's just pretty expected in the data space. What you want to do is, you don't want to put yourself in a situation where you are always compromising your response time based on the data growth. So you need to find a way, how do you distribute the data so that you can break this curve and say, as the data volume increases, your response time is not a linear growth. At some point of time, you need to say, I want to go steady response time. How do you achieve that? So that means you need to take the table and then you need to find a way to distribute the data set so that your data set is not always, you're not getting one table where you are going to go into this kind of a mode. Instead of that, if you take the table and distribute across multiple hardwares, then you find a way to respond. You are basically dividing the query into multiple chunks, and then you go to the respective hardware and the database that's running on the hardware, and then you are basically marrying the individual query back. It will go to the response time. In this way, you can really find a way to scale this approach where, as the data volume increases, you can also distribute the data across multiple hardware, and then you can make your response time to be very consistent, almost in a way where you can predict. In general, most of the time, you have uniform data, okay? Then you have group, and then you have randomness, and then you have distinct data set. Okay, so now let's talk about each data set. Uniform data set. So if you take like a user table, or just a practical reason, you take a user or you take a contact, the data within the user table is a very uniform data, right? And then you have a characteristics of the users. So you want to make sure you are logically grouping the data based on the nature of the data set. Randomness is basically you have a completely different data sets where you have a logical way of mapping the data set so that you get a consistent result back. Distinct is, it's a very unique, you know where the distribution happens. So those are the 4 ways we are classifying the data set. So let's take this data set and then we'll talk about how we map it to a sharding technique. So from going forward, I'm going to call, this is called a vertical. This is basically called range. For random, I'm going to call key based, hash key based. This is basically a directory lookup kind of thing.